Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video on trigonometry and the unit circle is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. The unit circle is created from the equation x squared plus y squared equals 1. This equation describes a circle with radius equal to 1. Since the circumference of a circle equals pi times the diameter, this circle will have a circumference of 2 pi. Note that if we apply the Pythagorean theorem to the inscribed triangle, we can also arrive at the same equation. If the unit circle has a radius of 1, then it has a circumference of 2 pi, meaning if one travels around the 360 degrees of the unit circle, the distance traveled will be 2 times pi. This distance is called the arc length. Therefore, halfway around the unit circle, or 180 degrees, equals an arc length of pi, and 90 degrees equals pi over 2. The radian measure of a central angle is defined to be the arc length divided by the radius. Since the radius of the unit circle is 1, in this case, the arc length equals the radian measure. Knowing this, we can convert any angle described within the circle as a reference to this radian measure. For example, 360 degrees is equal to 2 pi radians. 90 degrees is equal to pi over 2 radians. 180 degrees is equal to pi radians. And 270 degrees is equal to 3 pi over 2 radians. We can now convert any degree measurement to the equivalent radians by taking the number in degrees and multiplying it by pi over 180. In the example given, we convert 45 degrees by multiplying it by pi over 180. 45 pi over 180 can be simplified to pi over 4. The terminal point on the unit circle is the xy coordinate of any particular point on that circle. This point, by definition, will give us the length of the sides of the inscribed triangle. This can be solved with the same equation from the start of the lesson, x squared plus y squared equals 1. With a 45-degree angle, both x and y will be the same. So we can solve instead x squared plus x squared equals 1, or 2x squared equals 1. Divide both sides by 2, leaving x squared equals 1/2. Square root both sides so that x equals 1 over the square root of 2. If we rationalize the denominator, we'll come up with the final answer, x equals the square root of 2 over 2. Since y will be the same, our terminal point is square root of 2 over 2, square root of 2 over 2. Note that we use the positive, but the square root property tells us that x can also equal negative square root of 2 over 2. This will become evident in the next section of the lesson. The unit circle can be divided into 4 different quadrants that will have different signs with similar angles. We've already worked in quadrant 1, where the 45-degree angle touches the unit circle at the point square root of 2 over 2, square root of 2 over 2. If the angle, however, exists in quadrant 2, the 45-degree angle may still be used, except the x term needs to be negative. Negative square root of 2 over 2, square root of 2 over 2. In quadrant 3, both x and y is negative. Negative square root of 2 over 2, negative square root of 2 over 2. In quadrant 4, the y term is negative. Square root of 2 over 2, negative square root of 2 over 2. Once the terminal points are known and related to the angle of the right triangle inscribed in the unit circle, a relationship can be made between the two. These relationships are known as the trigonometric functions. Let the inscribed angle be theta. Sine theta equals the opposite side over the hypotenuse. In the unit circle, that would be y over 1 or y. Cosine theta is the adjacent side over the hypotenuse, which in the unit circle is x over 1 or x. The tangent of theta is the opposite side over the adjacent side, which in the unit circle is y over x. For our examples, we'll use theta equals 45 degrees. Sine 45 degrees equals the opposite over the hypotenuse, or square root of 2 over 2. Cosine 45 degrees equals the adjacent side over the hypotenuse, or the square root of 2 over 2. The tangent of 45 degrees is the opposite side over the adjacent, or square root of 2 over 2 over square root of 2 over 2, which equals 1. In addition to sine, cosine, and tangent, there are three additional functions that act as reciprocals of the first three. Cosecant theta equals the hypotenuse over the opposite side, which is the reciprocal of sine. Secant theta is the hypotenuse over the adjacent side, which is the reciprocal of cosine. And cotangent theta is the adjacent side over the opposite side, or the reciprocal of tangent. The completed unit circle is the quickest method of solving sine, cosine, tangent, cosecant, secant, and cotangent functions for the most common angles. Most math students keep a copy of this as a quick reference. The first example is cosine 4 pi over 3. We find 4 pi over 3 in quadrant 3, where the x component will be negative, in this case negative 1/2. The second example is sine of 120 degrees. We find this in quadrant 2. With sine, we look for the y component is positive square root of 3 over 2. In the third example, we have tangent 11 pi over 6. We find that angle in quadrant 4, where the y component is negative 1/2 and the x component is square root of 3 over 2. Setting y over x, we can simplify to negative 1 over the square root of 3. By rationalizing the denominator, we have the final answer, negative square root of 3 over 3. We remember from previous lessons that an inverse of a function is one that reverses the action of a function. For example, f of x is equal to y and g of y equals x. These functions are inverses of each other because g of y reverses the action of f of x. We can also write an inverse function in a different way by using a negative 1 exponent symbol over the function. F of negative 1 of x is equal to g of y. Do the trig functions have inverses? No, not without help. Why? Let's look at an example. Sine pi over 6 equals 1/2, and sine 5 pi over 6 equals 1/2. Therefore, any inverse function would not be a function at all. In order to have an inverse function, we must have a one-to-one relationship between the domain and the range. Thankfully, there is a workaround. If we restrict the domain of our trig functions, the inverse functions will work. Let's take our same sine function, sine pi over 6 equals 1/2. If we consider the sine function on the interval from negative pi over 2 to pi over 2, then the inverse function will only have one answer. The inverse sine of 1/2 equals pi over 6. Each trig function must also be considered on an interval that creates only one answer for the inverse. If cosine theta equals y is on the interval 0 to pi, then the inverse cosine of y equals theta. If tangent theta equals y is on the interval from negative pi over 2 to pi over 2, then the inverse tangent of y equals theta. The inverse sine is often called the arcsine. The inverse cosine is often called arccosine, and the inverse tangent is often called arctangent. Putting everything in this lesson together, we can now solve for many unknown elements of the right triangle. In this example, the side of the triangle adjacent to the known 60-degree angle has a non-unit value of 20. The opposite side is listed as x and the hypotenuse is y. To find y, we remember that cosine is the adjacent over the hypotenuse, so cosine 60 degrees is equal to 20 over y. If we solve for y, we get y is equal to 20 over cosine 60 degrees. Now let's reference the unit circle. We see that cosine 60 degrees equals 1/2. So we replace cosine 60 for 1/2 in our equation. When we simplify, we are left with y equals 40. We can also solve for x. Since tangent is the opposite over the adjacent, tangent 60 degrees is equal to x over 20. We solve for x so that x equals 20 times tangent 60 degrees. Again, we refer to our unit circle, which tells us that tangent 60 degrees equals square root of 3 over 2 over 1/2, which simplifies to square root of 3. 20 times square root of 3 can be left as the final answer, or you may express it as approximately equal to 34.64 units, rounded to the second decimal, whichever answer is required for your assignment. We can also solve for the angle if the sides are known. In this case, the opposite and the hypotenuse is known, so we use the sine function. Sine theta equals 3/6, which equals 1/2. We take the arcsine of both sides, since the arcsine of sine theta is theta. We can now see that we are looking for the arcsine of 1/2. Again, we refer to our unit circle, looking for a sine or a y component that equals 1/2. In this case, we can restrict our search to quadrant 1 since we are looking for an acute positive angle. The domain of sine in this problem will be the interval from 0 to pi/2. We find that 30 degrees is the correct angle, therefore theta is equal to 30 degrees. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you, and good luck with your studies.